What's up, everybody? In this video, we are going to learn how to create functions to control our motors. As you've seen in previous videos, we need to write a lot of lines of code to get the motors to move in a single direction. We'll create a series of functions we can use to tell the motors to drive forward, backward, stop, and to turn. Each function will only require one line of code to turn the motors. Start off by logging into Tinkercad using your course username. Select Circuits in the menu under your designs. You will see our motor driver circuit that we made in an earlier video. Hover over the circuit and click on the gear in the top right-hand corner. Select Duplicate. Click the name of our circuit in the top left corner and change the name to Motor Driver-Functions. Click on the Code tab and ensure the text drop-down is selected. Fill out the information in the header of our code. Update the program name and description. The program name is Motor Driver-Functions, and the description is a sketch where we will control motors using custom functions. If you look at the existing code we created, we used an analog write statement to send the speed of each motor. Try changing the values from 255 to any number between 0 and 255. Click Start Simulation, and you will see that the speed of the motor has changed. A value of 0 will send no power, and your wheel will stop. And a value of 255 will send full power, and your wheel will move as fast as it can. Let's write a function to control the speed of the motors. Remember, a function is a reusable piece of code that we can call in our programs. Above the analog write statements, type set speed, open bracket, 255, 255, close bracket, semicolon. In the code we just typed, we are calling a function called set speed, and are passing two parameters. This will be the speed of the wheels. Now we need to define the function below the loop. Type void set speed, open bracket, int left speed value, comma, int right speed value, close bracket, open curly brace, close curly brace. We just created the function set speed, and it will accept two parameters, the speed value for the left and right motors. Cut the analog write statements from the loop function and place them in the set speed function. Change the values of 255 to the variable names in the function declaration, left speed value and right speed value. Click Start Simulation and you should see the wheels move. Try changing the values in the set speed function call in the main loop. For example, change one value to 0. When you start the simulation, you will see one motor has stopped and the other is moving. Try some different values ranging from 0 to 255 and see how it affects the speed of the motors. Now we will write some other functions for our motors. When we write our functions, we want to be able to control how fast the motors move and which direction each motor moves. We will use the existing code that moves the motors forwards to build our first function. We will then edit the code to make other functions. Let's create a function to move the motors forwards. Most of our coding is complete. Let's write out our function with parameters so we can see what we need when defining the function. Type forward, open bracket, 255, 255, 1000, close bracket, semicolon, in our loop function. You can probably guess what the first two parameters are, the speed of the motors. However, what's the third? The third will be the delay, or how long we want the direction of the motors to execute. Let's create the function. Below the set speed function, type void forward, open bracket, int left speed, int right speed, int how long, close bracket, open curly brace, close curly brace. Great, we made a function called forward that will accept a speed for both wheels and how long it will drive in that direction. Now we need to add some code that will execute when we call the function. We've actually written our code for the function. It is in the main loop. Go ahead and cut from set speed down to delay. and paste it inside the curly braces of the forward function. Update the parameters in setSpeed to the variables from the function, left speed and right speed. Last, update the delay value and how long variable. Awesome! We now have a function to tell our motors to move forward, and we can control the speed of each motor and how long the function will execute. I'm going to add some comments inside the forward function that will be helpful reminders for what the code is doing. First, add the comment, calls the setSpeed function, and controls the speed of each motor before the setSpeed function. Next, add the comment, left motor moves forward before the digital write left A high statement, and the comment, right motor moves forward before the digital write right A high statement. Last, add the comment, motors will move for the length of the delay above the delay function. I've added these comments so when we make new functions, we can see what we will need to change. Click Start Simulation to test the circuit. You should see both wheels move forward. Great! We've taken our code and put it inside a function that we can reuse. Let's create some more functions. Go back to the loop function, and below the forward function, type backward, open bracket, 255, 255, 1000, close bracket, semicolon. This function accepts the same parameters as the forward function, except we want to change the direction of the motors. Remember, the direction of the motors is controlled by the digital outputs from the Arduino. Copy the forward function and paste it below itself. Change the name from forward to backward. Change the digital write values that are high to low and the low values to high. This will reverse the direction of the motors. Click Start Simulation, and you should see the motors move forward, then backward, and then the loop will repeat over and over again. You will also notice, in the main loop function, we no longer have a delay. This is inside of our forward and backward functions. Let's go ahead and call 3 more functions in our loop function. Below the backward function, type left, open bracket, 255, 255, 1000, close bracket, semicolon, then right, open bracket, 255, 255, 1000, close bracket, semicolon. Next, stop, open bracket, 1000, close bracket, semicolon. You will notice for the stop function that there is only one parameter. This is because we know the speed for the wheels, 0, and we only pass a delay. Copy and paste the backward function below itself. Change the function name to left. To turn left, we want the left motor moving forward and the right motor moving backward. Swap the high and low values for the left A and B digital write statements. Copy and paste the backward function below the left function. Change the function name to right. To turn right, we want the right motor moving forward and the left motor moving backward. Swap the high and low values for the right A and B digital write statements. Copy and paste the backward function below the right function. Change the function name to stop. Remove the int left speed and int right speed parameters. Change the set speed values to 0. To stop the motors, all outputs should be high or low. Change all digital write values to low. Click Start Simulation. You should see the loop function execute through the program and change the direction of the motors. We now have a series of functions we can use to change the direction of the motors and control where your robot moves. As you test this code when you build the circuit, try sending different speeds to the wheels and see how the robot reacts. The next step is to connect some input values to control the behavior of your robot. At the end of this video, you should have a better understanding of how to write functions to control the different directions for your robot.